In this lesson, we're going to review word equations, skeleton equations, and balancing equations. So word equations just tell us what reactants and products are involved in a reaction. It gives the name of each of those substances, but there is no chemical formula or a relative number of atoms given. Skeleton equation tells us the chemical formula for each of the reactants and products. It shows the physical state of each of those, so solid, liquid, gas, or aqueous if it's dissolved in water. And it does not show the relative number of atoms, molecules, or ions in a balanced equation. A balanced equation, on the other hand, gives us the chemical formula for each reactant and product, the physical state, and also the relative number of atoms, molecules, and ions in a balanced equation. So some things to look out for when we are coming up with a word equation. If we see reacts with or are combined or and, that means that we have reactants and we need to put a plus sign in between them. The and can also be products, but reacts with and are combined, those are telling us that they are reactants, and we have more than one, so we need a plus sign in between them. To form or produces means that whatever we had before is going to make our products, so we need an arrow in between our reactants and our products. React to form, so that gives us whatever we're told is reacting to form. Those are our reactants or the original substances. We need plus signs between any of the different substances and then an arrow after them. And decomposes, that means that that is a reactant that is going to be broken down into smaller substances. So let's look at a couple of examples. So solid calcium metal is placed in liquid water, producing aqueous calcium hydroxide and hydrogen gas. So we have this producing over here, that is separating our reactants. So we have calcium and water. Those are going to be reacting together to produce calcium hydroxide and hydrogen. So there we have our reactants and our products. The word producing splits them, and we have an and over here between the two different products, and solid calcium metal is placed in liquid water, so separating our two reactants there. So in our word equation, we are not going to have any of the descriptors, so just what the substance is. So this is calcium, this is water. We are told that it's liquid water, we are told that calcium is a metal and that it's solid, but those are not going to be part of the equations. We will use some of those in the skeleton and balanced equations as symbols after the reactant and products. So we have to start with calcium react with water. So those are the two reactants, and then they are going to produce, so we need an arrow, calcium hydroxide and hydrogen. So we have plus signs separating out our different reactants and our different products. Then for our skeleton equation, we would need to have the chemical formula for each of these elements and compounds, and then also identify what state they are, but we will not balance. So calcium is just Ca, so that is an element, and we're told that it is solid calcium, so we're going to put in brackets as a subscript an S. Water, we're told, is liquid, and water is H2O. And usually we make the L for liquid curved L so that it is obvious that it's an L and not a 1. So those are our reactants, and our products are calcium hydroxide. So calcium is in group 2. And so it has 2 valence electrons, and when it becomes an ion, it is likely to lose those 2, so it is more positively charged. So calcium's a 2+, and hydroxide we can find over here, and hydroxide is a 1-. So we have a 2+, hydroxide is a 1-, so as we crisscross, calcium is 1, and we need 2 hydroxides. So we have Ca bracket OH2. Now calcium hydroxide, because we found valences and did our crisscross, this is an ionic bond. So we have 2 electrons that are going to be lost from calcium. Each of the hydroxide ions is going to take an electron, making it negatively charged. So here we have an ionic bond created by the attraction of the positive and negative ions. And ionic bonds are the strongest type of bond. So these are solids at room temperature because that bond is so strong. So it takes a lot of energy to break the force holding one calcium hydroxide to the next calcium hydroxide. So these are solids. However, because this reaction is taking place in water, ionic compounds tend to be aqueous in water. We will look in Unit 4 at figuring out which ones are and which ones aren't. So for now, we're just going to say anything that is ionic is, if we have water around, is AQ for aqueous. And then we have hydrogen gas. So we already know it's a gas. Now, hydrogen is one of our diatomic atoms, and on this chart we have Hofbrinkel the clown. So Hofbrinkel, his name comes from the different elements that are diatomic, which means we need 2 of each atom. So hydrogen has 1 electron in its outer shell. It only needs 2 though, because it's the first shell. And so once there's a second hydrogen around, they are both happy. So we need 2 hydrogen atoms to combine to make hydrogen. Oxygen has 6 electrons in its outer shell. And we're going to form a double bond here, and that makes both of those oxygen atoms stable. So oxygen is also 2. So each of these, fluorine, bromine, chlorine, and iodine, all have 7. And so there's a sharing of 1, so all of those are, the exact same. So we need 2 of each of those, and nitrogen has 5. And so we have a triple bond for nitrogen, and that makes those stable. So every single one of these is a diatomic element, which means we need 2 of them for the element. So hydrogen is H2. And we're already told that it's gas, although we also know that because we have 2 of the same atom, our delta En for the bond would be 0. So the sharing of electrons is completely equal, which makes it a non-polar molecule, which means that it is a non-polar, which means we only have London dispersion forces, and those are very weak, so it doesn't take very much energy at a very low temperature that would convert to a gas. It doesn't take a lot of energy to break the bonds that are holding the molecules near each other to go from a liquid to a gas. Okay, so there's our skeleton equation. So the next step is to write a balanced equation. So we're going to start with our skeleton equation and then figure out how many of each of these we're going to need to balance the equation. Okay, so calcium, we have 1 calcium here. We have water is made up of 1 oxygen bonded to 2 hydrogens. And then we have calcium hydroxide, so calcium is attached to an oxygen, which is attached to a hydrogen, and again on the other side. And then we have hydrogen gas, which is 2 hydrogens. So we can see we have 1 calcium here, 1 calcium here. We have 1 oxygen here and 2 over here. We have 2 hydrogens, 1, 2, 3, 4. So I'm going to need a second water to be able to provide the 2 oxygens and 1, 2, 3, 4 hydrogens. So if I have 1 calcium for every 2 waters, I can make 1 calcium hydroxide and 1 hydrogen. So that means to balance this, I just need 2 waters. So one of the ways you may have been shown is just to list all of the different elements. So I have calcium, oxygen, hydrogen, I have 1 here, I have 1 oxygen, 2 hydrogen, and on the other side, calcium, I have 1, oxygen, I have 2, and hydrogen, I have 4. So once we were to put the 2 in front of here, that would give us 2 oxygen and 4 hydrogen. So you're welcome to use whatever method works for you. Sometimes visually seeing the different atoms involved in each element and compound can help us to visualize and see why we are balancing, but you're also welcome to use this to keep track of those. Okay, let's do one more example together. So there's solid calcium oxide and carbon dioxide gas. So we have our and there, so that separates out 2 substances, are formed. So because these are formed, that means that those are actually our products. When solid calcium carbonate decomposes, so decomposes, that was a keyword to tell us that that's a reactant and it's going to break down into smaller things. So we have calcium carbonate is our reactant, and that's our only reactant, and that is going to break down to produce calcium oxide and carbon dioxide. So remember, we're not writing gas or solid or anything over here. So then we have to come up with our skeleton equation, for which we need the chemical formulas. So calcium we looked at in our last question, so that is a 2+. Carbonate, if we look over here, is CO3 2-. So we have calcium was a 2+, carbonate is CO3, and it has a valence of 2-. So 2 electrons are lost, 2 are gains, which means I only need them in a 1-to-1 ratio. So I have calcium carbonate, and I'm told that it's solid. And calcium oxide, so calcium is 2+ once again. Oxygen is in group 6, so it is more likely to gain 2 electrons than to lose 6. And once again, we have a 1-to-1 ratio. Calcium loses 2, oxygen will gain 2. So just CaO, and we're told that that is solid. So both of those are ionic compounds, gain and loss, and so that is ionic bonds. So they are very strong, which means if they're not in water, then they are going to be solid. So a lot of energy is required to break apart the bonds that, or the forces that are holding neighboring particles together. And then carbon dioxide, so 1 carbon dioxide, 2 oxygens, and we're told that that is gas. So carbon dioxide, even though the bonds are polar because it's a linear molecule, the bond dipoles are canceled out and it overall doesn't have a molecule dipole. So this is a non-polar molecule, even though there are polar bonds, and because of the nonpolar molecule, it has London dispersion forces, which are the weakest, so there is not a lot of energy needed to break apart the force that holds neighboring molecules together, which makes it very easy for those to be a gas. So at a fairly low temperature, it will reach its boiling point. Okay, so there's a skeleton equation. Now we just need to balance. So we have on this side calcium, carbon, and oxygen. We'll put them in the same order on this side. So over here we have 1 calcium, we have 1 carbon, and 3 oxygens. On this side we have 1 calcium, 1, 2, 3 oxygens, and 1 carbon. So we have 1 and 1, 1 and 1, 3 and 3. So this is not only our skeleton equation, in this case this is also our balanced equation. So 1 molecule of calcium carbonate will break down into 1 molecule of calcium oxide and 1 molecule of carbon dioxide.